Hello and welcome back. I guess we can slowly get started stream. It's 3 minutes earlier, but that should be okay, right? Again, full face cam. I managed to get it working, so it's all good. So we'll see how this goes. Let me just have a quick look around. Does this look okay? It looks okay. I seem positioned quite well. Awesome. So what are we going to be doing today? I plan for today that we play around with some EC2 stuff. Kind of like the back to basics stream. It's not going to be anything too complex. Folks who have just started using AWS or want to use AWS a bit more, this might be more useful to you all. But it's going to be useful for everybody because, hey, you get to watch my bald head. So that's all fun. Richard says, if you ain't early, you're late. Absolutely, right? That's a wise words there, Richard. So let me be early and let's kick it off. Let me switch my screens, right? So what are we gonna do? I need this here. Awesome. So we're gonna be looking at the management console today a lot. And what we're going to be trying to do here is we'll basically go through everybody keeps talking about serverless these days, and maybe containers and all those things, which absolutely is fine, and I talk about it as well. But let's talk about some people who run things on EC2 instances, which is pretty common, right? And let's see how can you make a web server or a set of web servers on EC2. So that's what we're going to be trying to do today. I'm going to kind of take you step by steps of how it all will look to set up EC2 instances as virtual machines, and maybe something like a load balancing and auto scaling and all those kind of things. So yeah, so where do we get started? First of all, I see 11 people on chat. So hello. I had a nice chat with them already before you saw my face, so that's pretty good. Hello and welcome to all. And I officially have a first subscriber. Like, somebody actually subscribed to my channel. That's something I don't expect. You don't have to do that, but it's okay. Thank you. So what are we going to be talking about today? The goal is to go through, create an EC2 instance, maybe do some networking, talk about auto-scaling groups, talk about load balancers, those kind of things. How would you set it up from scratch if you were doing it? Without anything, so I'm going a bit maybe sometimes outside of my best practice suggestions, like I do with infrastructure as code using CloudFormation, all that stuff. I'm not going to be focusing on CloudFormation today or anything like that. I'm going to be just being that little click boy who's going to, we're going to do infrastructure as click. So we're going to click a lot on the console. The whole reason I couldn't bring out my old laptop is, well, it's too slow to run this. But maybe some next time you get to see the old clunker. So where do we start? That's not my mouse. That's my mouse. Sorry, having the two mice on the table, that's not good. So where to get started, right? So what is EC2, right? And this happens to me a few times. I go to like a user group meetup, not even a user group meetup, but like a meetup or a talk, and fairly there are people who don't know what EC2 is, right? It's a service from AWS that maybe not everybody uses, especially people who don't use AWS, right? So EC2 is basically our main or our OG compute platform. This is where you would run virtual machines, right? So if you want a virtual machine, a Windows server, a Linux server, that's it. You can run it on EC2. So EC2 is basically, and the acronym is Elastic Cloud Compute. So the two is basically because there's two C's. Smart. And basically, what you do here is launch virtual machines and use them like any other server you would have to do it. And I mentioned this a few times. I come from a traditional, background. I worked in companies where we would host our own stuff internally in our data center, which was a data center. It was just a storage closet with a bunch of servers or something that acts like a server. And the way you would provision those, you would buy them, install software, use a CD, right? And that would work. We evolved. to using virtual machines, right? So I moved companies, and we had this newfangled thing called VMware at the time, and all virtual machines were the shit. Like, oh my god, you can just click a button and have a virtual machine. I can have infinite amounts of virtual machines. No, there's a limit, absolutely, right? How much you can, how much of them you can have without sacrificing, your production quality, but you still have the ability to kind of spin them up, do something, spin them down. So pretty cool, right? And now this EC2 is basically like that, but on a whole nother level. So think of this as a massive virtual machine pool, which you can infinitely, quote unquote, launch and use, right? So basically what we're going to be trying to do here is create a virtual machine, or create a bunch of virtual machines that are going to run our web application. Oh, by the way, I have a web application. Where can I paste the link from? So I have a GitHub page, and this is my fancy web application. Now, please, I know it's on GitHub, don't steal my source code. It's an index.html file. It's amazing. So it's full-blown HTML. It's just, yeah. You'll see what it is. Maybe somebody just notices from a glance on this, but I'll show you later on when we actually run this thing. Okay, so let's your task. You're a DevOps engineer, or whatever you would like to call yourself. You're a Linux admin. On his path to install a web server, you will told, we need a web server for our amazing application. You need to set up a web server. How does one do that? You go here and find a big red launch instance button, or a big orange launch instance button. And here, the first thing you're prompted from is which AMI, or Amazon Machine Image. Think of this as a golden image, or basically an operating system you're going to be choosing to launch your machine image from. You have the basics such as Red Hat, Ubuntu, SUSE. Richard says, what are indents? I call Jeff Amazon. Yes, Jeff Amazon at order one. Absolutely. So what are indents? Indents as in like text indentations? Or I don't know. By the way, this is coming from not Twitch chat, it's from Periscope chat. See, multi-streaming platform. So Ubuntu, SUSE, Red Hat, Windows, Windows 2008 R2, I believe the last one supported, and all the latest ones. Indents in your HTML file. Yes, there are no indents in my HTML file, and you will see why. Wait, give it a moment. Once we launch our website, you'll see why there are no indents. So for this use case, I'm gonna just use what's his face, Amazon Linux AMIs, right? I'm just gonna use the old one because security. It's because I'm used to this one, and I have a script that runs on this one. I don't wanna complicate things. It's a bit different when it comes to Amazon Linux too. So I've chosen Amazon Linux. Now the next part is I have to choose some compute options. This is where you choose the size of your virtual machine. So basically, what is the configuration of your virtual machine, how you want to do it. It's not very traditional, like if you do it on virtual machines, you don't get to pick, you don't have a slider to select number of cores or memory. You can literally pick instance families and types, ranging from T2 instances to, C5, M5, R5, and all those things. Like, from a super simple, cheap instance like a T2 Nano, which has only half a gig of RAM, to, something, I think the largest one is that X something, which has like 2 terabytes of RAM or something ridiculous like that. So 4 terabytes of RAM on this X16 something large, and that costs like I think $20,000 a month, ridiculous something. Yeah, but for our purpose, for our website, we're fine with just using a T2 micro instance. That should be okay. Now, one thing you have to take note when using T-type instances or instances in the T family, unless you're selecting the unlimited option, the T instances are good for burstable workloads. So if you have a workload which is burstable, all of a sudden you have some spikes, they take it up and just nothing happens ever again. They're good for that. But if you have a constant load, they might cause you a problem because they have a thing called credits, which kind of generate over time. And if you start using a certain amount of CPU utilization, those credits gets wasted, and if you lose credits, you might get throttled, etc. So make sure if you're using something that has a constant load, when I say load, I mean an actual load, make sure to maybe pick something other than the T instances or select the unlimited option. let's go with a newer tier here. I'm gonna select the T3, well, T3 micro. That should be fine, right? Do my face because I cannot see the clicks here. Okay, cool. I selected this one, two cores, 1 gig of RAM. It should be sufficient for my web application, right? Not ridiculous. It's what ADOS. Yes, actually. All right, there you go. So you can use basically those huge instances for running SAP HANA because yeah, you need so much memory, as Luton first says. Yeah, absolutely. There are use cases. It's ridiculous, but trust me, for my website, I think 4 terabytes of RAM would be a lot. But yeah, let's move on. So I select my instance here. That's all fine. Oh, Richard says use P5. Absolutely P5. I know I want to do machine learning with my index HTML file. All right. I have basically, here's a bunch of things I can configure. One of the things you can select is a number of instances to launch. This, to be fair, is not super useful unless you want to launch an X amount of independent EC2 instances to do something with them. You know, you can kind of ignore that for the time being. I'm not going to worry about that. I'm just going to use one in this case. Now, important part, VPCs, right? So VPCs, or virtual private, what is VPC? Virtual private connection? Basically, think of it as a network, as a virtual network within AWS, right? So this is where your subnet sits. This is where your security, internet gateways, NAT, all things connected, related to networking, right? So are sitting in. Okay, so Richard suggested that I use a P5 instance because of machine learning, right? And how are you going to get VC funding if you're not using TensorFlow for all of your HTMLs? Absolutely. We need TensorFlow to run our HTML, right? Because that's how it works. Yeah, we need funding. We need to put maybe some blockchain. Maybe we update our application for blockchain. So VPCs, yes. So we want to choose a network here that we're going to be using for our instances, right? Basically, what networks is our instance going to sit in? I have this summer tour network that I created a while ago, so I'm going to be using that one because I know it works. A couple of other, I can choose a subnet which you're going to sit in. I'm just going to choose the default one. I want this instance to have a public IP address, so because I want to just reach into it, I want to see how it works, right? I will enable the assignment of a EC2 instance of a public IP. And for the rest of the things, yeah, that's fine. I don't want to care about these things. I will not set a role. Kaudin says U24TB1 metal for Minecraft. Yes, we're not building a Minecraft server today, but yeah, maybe something like that. Something huge as such a thing. IAM role, I'm gonna skip that. Basically, that's giving us a specific set of permissions for your EC2 instance. Today, right now, I don't need that, so I'm gonna skip that. I'm not gonna specify any CPU options, nothing in shutdown behavior. See, and this is the T2, T3 unlimited. I'm gonna enable it just to be safe, right? I'm just gonna leave that enabled. This basically overcomes all the problems when it comes to credit usage on T2 instances. Network, I'm gonna have a single network address here. That's all fine, and everything else I'm just gonna completely ignore. Going to storage, by default it gives us 8 gigs of storage, which kind of comes into the free tier, but I'm going to add more because splurging. And should I encrypt things? I'm not. I'm just going to leave it as such, but you should encrypt your volumes if you can. Give our instances a name. So let me give a name. This is just a tag called name, just going to show up with the name. So stream web server TensorFlow, right? So it's not TensorFlow, I'm just joking. So it's gonna tag both instances and the volumes attached to it. So the volume, the disk attached to it is basically an EBS volume. It's gonna be presented as a logical disk connected directly to the instance, but it's basically sitting on the network somewhere. So it's sitting outside of this current instance, but it's being attached as such, and it's a separate entity within AWS, which you can manually work with that volume. Oh, hey, Richard is on Twitch as well. Hey, Richard, double viewing, yes, double the EC2. So going forward, we need to configure a security group. Now, security group is this. Think of it as a firewall attached directly to the EC2 instance, and this is where you control basically your inbound and outbound rules, right? So Paul asks, will this be on YouTube? Absolutely. I'm going to post this on YouTube later on. Well, as soon as I'm finished and have it all cut up and posted. So it will be there. Absolutely. Also on Twitch. So Twitch keeps this recording for a while as well. Awesome. So security group firewall attached to instance. We can decide. We can set up things here that say, you know what, which IP address is allowed to access this instance from where and what port. A firewall, right? So let's do this. SSH stream, right? And maybe well, let's do this. Stream EC2. Used for my web servers. Cool. SSH from anywhere? No. I'm gonna use my IP. You get to see my IP address. I'm gonna add a new rule here, and I'm gonna allow web traffic to come in, right? But it's gonna be from anywhere, right? So I'm gonna just do that. That's fine. I only need port 80 and port 22 to kind of work with my instance right now. Review and launch. That's fine. Click launch. Now, the important question, and a lot of people kind of miss this sometimes, is make sure to select a key pair. The key pair is basically a key pair which you have created before on your AWS account that gives you access to these EC2 instances. So you're able to SSH in those instances by the use of that PEM key, basically. So I will use this one. I acknowledge that I have access to the key, because if you don't have access, it's sometimes a problem reattaching to this instance. You can do it if you lose your key. There's ways to do it, but it's not the easiest thing in the world. But okay, I'm gonna choose an existing key, and that should be fine. Click launch. Now we can see that this instance is launching now. Okay, cool. We see it here. It's in the pending status. Now it's being provisioned. You're going to be basically, it's spinning up an instance somewhere on Amazon's, well, currently in Frankfurt in one of our data centers on a big old rack with a bunch of machines and running on Amazon. What is the name of the Nitro, right? Our virtualization platform. So yeah, it takes a couple of minutes. It takes a bit longer depending on which OS you're using, but you can actually follow the progress of it booting up in the get system log. Now again, it's blank because nothing has happened yet, but in time, you will see here basically the boot log or the startup log of an EC2 instance. And also one of the things you can do as well, which wasn't existing when I joined AWS, is you can get an instant screenshot. See, you see that there's a actual Amazon Linux machine running here, and it seems booted. Just the logs have not shown up. So let me just do a stream like that. I have this instance running. Okay, cool. If I click connect, I should be, basically it gives me a couple of options. A standalone SSH client, right? Just connecting like this, using a session manager from systems manager. We're not going to do that right now. And also just give me this thing that I can connect with, right? Just a connection string. I just usually do that and open up my terminal. Make that bigger. Ooh, tmux. SSH into it and just like that. Whoop, bam. Cool, I am in my Linux server. Oh, where am I? Who am I? I'm EC2 user. Page top, is this installed? It's not. So DFSH, 30 gigs, yep, free, 1 gig of RAM. So what's the next thing we need to do? Well, you need to install something to basically act this as a web server, because if we go on this side and we look at its, so we have this public IP address of it, right? If I do here, nah, there's nothing there, right? There, it's a connection refused. Nothing is listening on our EC2 instance. So we need to install a web server. Now, this is not a discussion how you install a web server, but I'll just do it, right? So I'm gonna install Nginx and host my web application here, right? So sudo yum y update. Yum is the package manager Amazon Linux. I'm gonna updating just its thing. That's fine. Yum y install Nginx and git. I think that's all the things I need. Yeah. So I'm installing Nginx as the web server. I'm using Git because I need Git. Now, I mentioned that amazing web application I have right now. But what I'm gonna do right now is I'm gonna Git clone this application into a directory So I need to remove that directory. Sudo rm rf usr share nginx html. Okay, cool. Rm. Let's go. Okay, cool. Now, if I just run this git command will clone that repository that you've seen here with my unindented HTML files. It's going to clone that directory. Basically, it's going to clone the index.html, copy that index.html inside of the nginx root directory, right? Basically, where the files are going to be served. That's fine. So if I ls sudo ls usr share nginx html, I see that file, right? So if I just restart nginx, sudo right? Okay, so it has stopped. Well, it didn't stop because nginx was running, but it has started nginx right now. And start. Just want to see that's not my command here, right? But there we go. I can see that something is listening on port 80, and to see what is the listening, I can see that nginx is listening on port 80. So our web server is actually running right now. If I go here again, oh, there you go. You get to see my amazing website. So for Richard, who has asked here, the reason there's no indentation is in this HTML, because this HTML is, it's 25 years old, from 1993. So yeah, it's a bit old. So this is the first website ever, right? So the first www website hosted in CERN, right, from 1993, I believe. So yeah, it's just this page. It doesn't have any of the other pages. I was too lazy to look for the sources of the other ones, but this is how an actual website should look, right? So if you want the actual experience, you should use a line browser or something like that, but we're not gonna be doing that now. So okay, we have our web server running. Wow, that's amazing, right? So this is great. But that was a lot of work. That was too much, right? I had to, do a lot of different things, and create an instance, SSH into an instance, install a web server, do all those things. Of course, it would take me maybe less time if I wasn't talking to, out loud. But still, it takes time. Let's say all of a sudden, this website is so amazing, right? This is great, and everybody wants to, come join our TensorFlow Worldwide Web project. And this T3 instance is not enough, right? How do I manage to, scale up or do something, increases the performance of it? In the old days, you would probably just, have some downtime, spin up a bigger server, and just restart it again. That's fine. But we can do that same here. We can resize this instance. I think you can just go here and right click instance settings, and you can change instance type. If the instance is stopped, you can change this type to something bigger, right? But that's less than ideal, right? How can we do this automatic, or how is this done properly? What's the best practice for this case? Well, it's the usage of autoscaling groups, right? So we need to use something called an autoscaling group, which is basically a kind of a, if you think of it, it's a collection of, it's basically a service from AWS that automatically scales your instances for a specific thing, right? So you kind of tell it, hey, this is the instance I'm gonna launch. This is how you're gonna launch it. Please auto scale based on this criteria. Like, for example, if you have CPU utilization bigger than X, scale up. And when it's less than that, scale down. So it's able to, automatically scale up and down, given on a couple of terms you set it. So it really depends on what you do. It also gives the ability to use something called a load balancer, or elastic load balancer, that sits in front of your EC2 instances and serves traffic for your EC2 instances. Basically, it kind of disseminates traffic between your multiple instances in that autoscaling group. So that means even if you would have 100 EC2 instances, the load balancer would kind of manage the connections between them, or manage your customer incoming connections to them, and disseminate them across them. So let's do that, right? I think that's the better option here, because my small website will not survive if we have a lot of people here. So yeah, please tweet my website. okay, let's kill our website. Well, actually, let's leave it running for the time being. But what we need to do here, what's the first thing we need to do? We need to create, so when doing autoscaling groups, there's two ways to do it, right? So if you click create autoscaling group, there's the old way by the use of launch configurations, or by the use of launch templates, which is something new, right? So launch templates are something new that's been, I don't remember when it was released, but it's relatively new in this. It wasn't here when I joined AWS, which was 4 years ago. So let's use launch templates, right? Let's use launch templates. I have some existing here, but I'm gonna ignore them and I'm gonna create a new one, just so I can show this to you all. Cool. So template name. Let's go template name, right? So let's call it stream right? So hey Paul, just putting together a document to create a fault tolerant website using the architecture framework. Yep, there you go. That's this is so this is all in line with the well architecture framework, which I'm doing, right? The proper part's not me joking on a single instance, but yes, use of Route 53, application load balancer, EC2, autoscaling groups, yeah, having RDS or relational databases across multiple availability zones. Yep. So welcome, Paul. Okay, cool. Give it a name. I'll have my template description. Create. Awesome. We only miss next cubes for this one, right? I'm gonna leave everything like that. I want to pick an AMI, right? The same thing I did before. I want to make sure I pick the AMI. I'll pick the same AMI I used before. I want to define which type instance I want to run. Again, I'll be fine with T3 because we can have multiples of them, so T3 should be okay, right? Let me just, what can't I find this? Oh, sorry. T3 micro should be okay, right? I'm gonna just use this key pair. Now, I'm gonna select a key pair, but I won't need it, and you'll see the reason why we won't need it. I want to make sure to select a security group. Now, I want to select this security group that I created before. It's called Stream EC2. Yeah. The root volume, I'll leave it at 8 gigs. This is perfectly fine. I don't need to change this, right? I can modify this. Also, I can pick different volume types. So we have a few volume type difference. I haven't actually spoken about this, but the general purpose SSDs is basically the run-of-the-mill general purpose disks you will most likely use. But you also have things such as magnetic storage for, like, you know, if you have some, it's cheaper and you have some archiving data or some data which you don't access as frequently, magnetic storage might be okay. Or things such as throughput optimized disks, which are great for, you know, data throughput. Or if you need really a lot of performance, provision IOPS SSD is where you actually provision the amount of IOPS you require per disk. So, but I'm gonna leave it just at this. Also, one thing I missed as well, and this doesn't get mentioned as much, when you launch an EC2 instance, there's two types of EC2 instances. There's EBS backed, the ones with volumes coming from EBS or Elastic Block Store, and there's also instance store instances. So instance store instances are the ones which have disks on them. So they have literally physical disks located within the same chassis, right? The same virtualization box. So the performance is slightly better, but all the disks are ephemeral. So it means when you stop your instance and start it up again, bye-bye data, right? So don't keep data on those instance types. Make sure to offload the data to a EBS volume or somewhere else, right? So I'm just gonna keep it as such. I'll add some tags. I want to do this. I want an application. I want to tag my instance properly. Application. And gonna call it www. That's fine. I'm gonna tag both volumes and www. Yes, like that. I'm not gonna do any network interfaces for this case. So I don't want to do anything special to these instances besides just this, right? Well, if I do this, no, I don't want to do anything special, right? It's gonna create network interfaces as default. But for some advanced details, I want to do something here. Right? I want to include an IAM profile. I want to make sure that I give my instance an IAM profile because I want to do something with my instance coming later on. but I just want to show you this. So I'm looking for a profile that has SSM in its name, right? SSM EC2 role. So I'll talk about this later on once I get to it. But basically, this gives my instance some permissions, which is this instance profile has. So my instance can basically assume this role and do something. When I run commands on it or with it, it has some permissions coming from that role. And finally, I want to select T3 Unlimited because why not? And one more thing I need to talk about, and this is a very important thing when it comes to autoscaling groups, especially if you're not using your own Amazon machine images or AMIs, but you want to use a generic AMI and do something on it. So you remember when I did the magic with CLI and installed all this fancy things, right? So if I go here, right? You see me doing all of these things here. That's great, right? That's amazing. But how can we do this automatically, right? So the thing we can do here is that we can actually use something called user data, right? And user data is this option within EC2 that gives us the ability to automatically run a script, a specific bash or PowerShell script during the instance boot time. The first time it boots, the first time you click that start button, this script will run and then it will do something. So instead of me going in and typing all of this stuff, let me just create a script out of it, right? So let me just do this. This is not required, but I'm just showing off. Let me no, like that. That's not the character I want. Is it this? Yes. Actually, because this is running as root, I can just do this. Do that. That. Git clone. I don't need this, and that's it, right? So basically, what this will do right now, it will run an update. It will update yum. It will. I need to add this as well because it's a bash script. Bin bash. It will update. It will update yum. It will install nginx in git. It will remove this directory like that. It will git clone this thing to that directory, and it will start nginx. Right. So if I just do this, or no, let's. Goody, and go here and paste it. So I'm basically pasting a bash script within this little window, and that's it. Does it all look nginx, rmrf, git clone? Good. Create launch template. So we have created our launch template, and now it's time to create an autoscaling group. So let's call this servers. I will use the latest or the default version. I'm just going to choose the latest version of my launch template, and I'm going to start with 2 instances. If you run anything in an instance in a web server, have at least 2 of them, no matter what, no matter the load or not. It's not about the load. It's about just if something happens to one, you never know. You want to have one still running and not having to worry about it. I'll add it to this VPC, the summer tour one, which I showed you. And I'm going to select these subnets as well. On the advanced details, I want to do some load balancing, right? I forgot to add a load balancer. Okay, cancel and exit. So let's create a load balancer, right? If we go to load balancers, we need to create a load balancer, something that will basically, balance the load between my instances in my autoscaling group. I'm not sure about you all, but internet here in Germany has not been super great in the last few days. I know everybody's at home and all that stuff, so I see some impact, especially sometimes when it comes to DNS. So create a load balancer. I'm going to use an application load balancer, which is basically that. There's a classic old school load balancer. I'm going to completely ignore that. And the network load balancer is basically for non-HTTP or HTTPS traffic. It's basically for TLS, TCP, and UDP traffic, but I'm not going to worry about that. I'm going to create an application load balancer. Give it a name, .lb. I'm going to face it towards the internet, so I'm going to make sure it's internet facing. I'm going to just listen on port 80. And I want to select a VPC, the summer tour. That's fine. I'm gonna select all the AZs. because I want my load balancers to be able to listen into all AZs. Now, there's one more thing you can do with load balancer, which I'm not going to do here because I don't have that set up right now, but you can also select HTTPS. So the load balancer will be basically HTTPS termination, where you can have a front-facing load balancer which has HTTPS enabled on it, and it will terminate customer HTTPS traffic on it, and then internally it can go through HTTP to your EC2 instance. So you don't have to set up certificates, anything locally like that, but load balancer can do that for you. I'm gonna ignore that right now. I'm gonna just set it up as just having HTTP just only, because if I HTTPS, I need to have a certificate ready, and I don't. Well, I have to request a certificate from AWS, and I don't have that right now. So configure security groups. That's fine. Security settings, actually. Now it's security groups. Let's actually create a new security group. I'm gonna call it LBSG. And I'm gonna just allow anything from 80. That's fine. So stream SG for LB. Next, let's go and configure routing. Now the routing part is the target group, right? So this is basically where your application load balancer will send traffic to once it receives it. I'm gonna create a new target group called servers, right? And I'm going to just use instances. In this case, I can specify IP addresses if I want. I can also specify Lambda functions, but not going to do that. I'm going to take HTTP to port 80 on these instances. One additional part of load balancers is they're able to sense health. So they're able to run health checks against your instances. For example, if the web server has stopped working on this web server, right? The load balancer will no longer send traffic to it, just as a health check. So it will check, it will basically keep checking the slash path every 30 seconds, right? Every 30 seconds it will attempt to get a 200 code from the path. And then if it considers an instance it being healthy. If the instance does not respond with a 200, it automatically says it's unhealthy, and it will throw it out of the pool. So it will not be serving traffic to it anymore. So I'm gonna just do that like that. Now you can manually register targets. I can add my old EC2 instance to this one, but I'm not. I mean, it wouldn't make sense in this case because I already want to create an auto-scaling group. So I'm just gonna completely skip this. I'm not gonna add anything here. Click review and click create. So my load balancer has been successfully created. It does take a couple of minutes for it to provision, because in the backend it basically just creates a whole bunch of infrastructure for you to have these load balancers sitting within the given availability zones and subnets you have created. So while that's provisioning, we can go back to create our auto-scaling group again. So I'll click this button again, launch template, and I have my launch template for this. How did we call it? Servers. I'll just use the latest one. Make sure I set with 2 instances. As such, proper VPC, proper subnet, like that. I'll make sure to use all the subnets. And now on the load advanced details, I can select receive traffic from one or more load balancers. And I'm gonna select my target group here, which is called servers. Yes, that's the one we created. And that's it. So it's gonna basically take a health check from those instances as well. And that's it. I don't have to do anything here. I'm going to configure scaling policies. So this is where I talked about scaling policies. This is where you can kind of have auto scaling automatically go, scale up or scale down your instances depending on certain parameters like CPU load, memory, well, anything you want basically. So I want to use some scaling policies. So I want to scale between 2 and 10 instances. I want to have a minimum of 2 instances inside of my account. Let me just zoom this in. I want to have at least 2 instances within my AWS account, right? So within this autoscaling group. And I want to do it based on an average of CPU utilization. So if my average CPU utilization is 50, over 50, it will scale, right? I want to say that my instances need 300 seconds is okay to warm up. So basically what we're doing here is telling autoscaling scaling policies that please wait 5 minutes once you have booted my instance, because it's warming up, it's installing files, it's doing all this. So the CPU utilization might be high. Don't try to attempt any scaling during that period. So that should be fine. If I click configure notifications, I'm not going to configure any notification in this case, but you can like set up a notification that will say, hey, you know what, send me an email every time you scale up or down, but that's useless in this case. Configure tags. I want to give some tags here. So name, I'll call those web servers, right? Cool. Click review and create. So we're creating a auto scaling group. So if I go here, by the way, I have not tried this out today. So if this fails miserably, we get to fix it together. Cool. So you can see here that we have 2 instances pending. So it has automatically created or started creating 2 EC2 instances that are going to be deployed. So like that. And you can see that the instance is not yet in service because basically it has not been provisioned yet. So it takes some moment or so. If I go here, so the instance is in service, but if we go back to load balancers and click there, going to listeners, we can see the target group we have created before. One of the things we should see here is targets. We can see that these 2 targets are currently healthy. So the load balancer right now is serving traffic to both of these EC2 instances. Okay, let's try to find out if we can target this. So this is my DNS name. We do that. Wabam, right? So I have my website now running on 2 EC2 instances. And the load balancer is basically load balancing that traffic between the 2. I don't know which one, but it is, right? So I don't have an option here to show you an instance ID, which is it. But trust me, if I keep refreshing this, at one point I'm getting one or the other instance being connected here. One thing I want to try, and this is the thing I haven't tested yet, is I want to try to trigger the scaling policies, right? So how can we do that? I mean, by just refreshing my page. It's a simple website which was running back in 1993. I think my EC2 instance will survive no matter what kind of traffic I give it at this point. But what can we do? Oh, I remember. We can do. There's this open source tool called Stress, right? We can stress our CPU on one of those instances. So let's try to do that. So one of the things we can do, actually, let's do this. So instead of connecting through SSH directly, let's use a bonus service for today called Systems Manager Session Manager. So this is something that is kind of a feature of Systems Manager. It's kind of a tool that does a lot of things. It's usually revolving around operations, but in this case, Session Manager gives you the ability to connect to this instance through SSH. But with the use of a web console. So I don't have to basically have the key with me. I just have permission to connect to my EC2 instance. So on my face again, I will select one of my web servers. Here you can see that's www web servers, and this is one of the IDs. I'll start the session here. And you can see here, it drops me into a shell. It's a shell. So I need to go to a bash shell. And again, who am I? I'm SM user, DFH. I can see that this is 8 gigs of storage. So it's that instance. So what can we do? We can do the stress command, right? So stress. Sudo yum. There. Okay. There's the package called stress. So stress is this tool that you can basically use to stress your EC2 instance. So you can impose a synthetic load on a machine, right? And we're going to try to do something here. Is there an example? Stress --CPU 8. That should be fine. Stress --CPU 8. Let's kill this instance. Okay, we're hogging as a CPU. If we go back to this thing, so which instance did we connect to? It's 99D. If we go here and we look some of the metrics or monitoring of this instance, we'll see that CPU is just 1. But let's enable detail monitoring, so we'll get notifications. We'll get monitoring every 1 minute. Otherwise, it's for 5 minutes. So we just give it a moment here until this picks up. So ideally what would happen right now if we would be going back to, let's go here. If we go back to EC2, once this specific threshold has been passed, the auto scaling should kick in, right? So the scaling policies should basically it should maintain the average CPU utilization at 50%. So if the average CPU utilization goes above 50%, this may be a problem. So the average is across all the instances here. So let's be smart and let's impose more stress on the other EC2 instance, just so we can be consistent. So going session manager, again, let's open up the other instance. I want to start a new session with this one, right? And start session. Okay. Bash sudo yum install stress. That's okay. Stress dash CPU 8. Cool. So we have stress now on both of these instances, and let's see, does this change anything? Now, if we go here, we should see our CPU utilization just growing. See, it's at 30%, and this will spike up pretty soon. So it should spike to 100% as well, and as well on the other other instance. So if I do www servers, right, it should be that should be okay. So both of these instances. Well, this one has detail monitoring, this one doesn't. Let me enable on this one. By the way, detail monitoring in CloudWatch costs a bit more, so if you enable it, please just take note that it might incur some additional costs as well. If I refresh this, I can see it jumping up slowly. This one is still at 30%. And if we go here, and if we go to the auto scaling monitoring, see, we're not we have not enabled group metrics, right? Okay, enable group metrics collection. Let's enable that. It takes some time for it to appear, so we can see the actual entire group metrics in this case. Standby instance, we can get all of these things. That's fine. On the activity things, on the activity history, this is where we should see a launch of an instance if this threshold is breached, right? So okay, we said 50% on this one. This one is at 6. Again, it takes a moment or so for this to follow up. I think it should take a few minutes, right, until this data is collected by CloudWatch. So in the meantime. Yeah, so let's have a look at this old application. I'm amazed by this. So nobody writes HTML like this anymore, right? So this is literally a copy of the original, the OG first website ever, right? So it's no indents. It's a very different. It's a very weird way to do it. They literally, write names for links. That's odd. So yeah, it's interesting. I think it's a piece of history. In any case, and if you want to check it out here, that's on CERN website. There's no CERN. It's that. Yes, this is the one. Yes, browse the first website. So yeah, this is it. And if you want to have a look at the other things, you can literally find other information, which browser you should use. Interesting. Yeah. This is like a technical implementation of HTML and the tags, and yeah, it's a time capsule. No, definitely. And when you look at today's modern websites filled with JavaScript and whatnot, HTML5, you see that we have gone a long way since those kind of websites. Okay, one of them is 100% now, so hopefully we should soon see the scaling policies triggered, right? Hopefully. So it should not show here, but it should actually show on this side because that doesn't collect like CPU utilization, the metrics for the auto scaling group itself. Let's have a look at this one. This one is clocking at 100%, and this one is also clocking at 100%. So it takes a moment or so for the scaling policies to kick in. But once they do, basically it will launch a new instance, and as soon as it launches that instance, it should be okay, right? Because we're adding a new instance, it should maybe add one more to keep that CPU utilization at 50% or below 50%. So think of it as a thermostat, right? It will keep it there, you know, it will not add new instances until you reach 50%, and as soon as you do or go over it, it will add more to kind of fall back to it. So it's a very simple way. You can make this much more complex by the usage of other things. You can literally scale based on any CloudWatch alarm. You can monitor things such as network traffic, or it's not always CPU utilization. So when I talk about, you know, auto scaling and auto scaling policies, it's not always about CPU utilization. It's not always a thing that saying, hey, you know what, you need to scale if my CPU is over 50%. Doesn't have to be, right? Some applications can get bottlenecked for different reasons, such as networking, disk I/O, you know, the number of sessions you have on them. That can also be a good reason for auto scaling. So, yeah. Okay. Nothing's happening yet, so maybe it just takes a while for this to kick in, but yeah. The policy should be executed. Basically, it's to require to maintain the average CPU utilization at 50%. Add or remove instances required. This should be fine. I think it has been more than 5 minutes since my instances have been started. Absolutely, yeah. So in essence, this should work. But what can I see here? Just the edit and delete, yeah. Yeah, at one point this should work, right? But to be fair, I have not played with these kind of scaling policies, the target tracking scaling. I've used the classical one, right? The old school one where you actually define a CloudWatch alarm to be triggered, and that one worked quite good. And this one should work good because it's much simpler to set up. But yeah, maybe I'm not giving enough stress to my EC2 instances for this to work, right? See, it's stuck at 100% right now. So yeah. In any case, what have we done here? We have basically created a setup where we have our web servers running in an auto scaling group, so it should automatically scale depending on a specific parameter I set. They're all sitting behind a load balancer, and we have also additionally created a user data script that will install a web server, copy my website onto it, and serve it. All these things kind of fall into this well-architected framework. Now, additionally, you would absolutely not just clone your web application during boot. You would most likely have some sort of a software delivery method, some sort of CI/CD pipeline, you know, using things such as CodeDeploy or Jenkins and whatnot. In a proper, you know, production scenario. I mean, I didn't have time to go into that, but this would be kind of a simple approach how to launch your first EC2 instance, how to set up a web server on it and just have it running. And one of the other things we did at the last point is we have not even enabled SSH to our EC2 instances. We have just basically connected through the use of Systems Manager, Session Manager, like so, right? It's pretty cool because you can do this through your browser. Without the need for a key or anything, of course, as long as you have permissions to do so. Yeah, I guess that's been the stream. So I didn't have any plan to talk about anything else. Oh, there you go. Scaling. Whoa, there you go. The demo worked. So the instance is basically launching right now, and we should hopefully soonish see that we have instances here like that. And if we go to load balancer and the listeners and the target groups, we see that we have 4 instances now, and all of those 4 instances should be running our website, right? So if I just keep refreshing, yeah, hopefully nothing fails. So yeah, it's working. There you go. Demo's worked. Cool. Let me just now kill my stresses here, and it should at one point, once this is all done, it takes a few minutes, right? it should scale down. So it will see that the average utilization is way below 50%, and it will remove some of those instances. Now, if we haven't set up the user data, no new instances would have the web server running on it, or the software installed, or anything like that. So I would have to do that manually, or have some external tool do it for me. This way, every time a new instance comes up, it basically runs all the same configuration. It creates copies of the website onto it, and just runs, right? So pretty neat. Yeah, that's fine. So, well, it's Thursday already, right? So it's almost Friday. It's almost the end of the week. And I hope you all had a nice weekend, and you will have a nice weekend going forward. My streams are happening every Tuesday and Thursday. I moved them up a bit to 6 p.m. CET, so because I do have a few viewers from the United States, and I want to make sure that I also can adhere to them. So it's gonna probably keep happening at 6 o'clock p.m. or CET. I'm not sure how much is that in American time, but depending on which time zone. But yeah, if you have any suggestions, any topics you would like me to cover, it can be beginner. I see a lot of people like beginner topics, or it can be something more advanced. I'm super happy to talk about anything. This is very relaxing for me, as you can see. I prefer streams to, delivering proper, white background presentations. It's a bit more relaxed, and I get to interact with the folks on chat as well. So most important thing, add Twitch emojis. Oh, can I add my own? Really? Oh yes, you can. Yeah, you can add your own Twitch emojis. Okay, I'll make sure to create something. I can make a Twitch emoji out of my little pixelated character. There you go. Awesome. I guess that's it. So if there's nothing else, folks, I wish you all an amazing weekend. Thank you very much for joining. Feel free to... I will be putting this up video on YouTube later on, and it's going to be also archived on Twitch, so you can basically check it out there as well. So, yeah. Thank you, Luca. Thank you very much. Once again, enjoy your weekend, and as we all say, stay safe out there. Thank you very much, and bye-bye.